Test y squared equals x plus 5 for symmetry. There's three types of symmetry. Is it symmetric with respect to the x-axis? Is it symmetric to the y-axis? And is it symmetric to the origin? Origin's the 0, 0 middle point in the Cartesian coordinate system. Let's first check the x-axis. Now, if you think about a graph, say you have an XY grid here. Now, if you have a point on the graph, say here, if it's symmetric to the x-axis, there has to be an opposite point straight across the x-axis on the other side of the graph as well. So you can see with this point, the x value stays the same, but the y value is opposite. So the way we test an equation to see if it's symmetric to the x-axis, we're going to plug in negative y, which would be this point, and see if we get the same x value as if we plugged in positive y. So what we're going to do is we're going to replace y with negative y and basically just see if the equation is the same. So I'm going to replace this y with negative y. And then I can simplify and see if the same equation comes out. So negative y squared, since the negative y is in parentheses and it's being squared, squaring a negative number makes it positive. So this is going to come out to y squared equals x plus 5. And you can see that the equation is the same. That means if we plug in positive or negative y value, the x value stays the same. So whatever the graph looks like here, it's going to be symmetric to the x-axis. So this would be yes. If you get the same equation when you plug in negative y, then it is symmetric to the x-axis. Now, if you think about the y-axis, if you think about the xy grid again here, wherever we have a point on the graph, say here, to be symmetric to the y-axis, we have to have an opposite point on the other side. So this time the y value stays the same, but the x values are opposite. So to test symmetry with respect to the y-axis, we're going to plug in negative x where the x value is, and then we'll just see if this equation is the same again. So I'm going to write the same equation, just plug in negative x where the x is. And then you determine if you can write the same equation or not. In this one, there's no way to write the same equation, because if I want to make this positive to match with this one, I'd have to multiply both sides by negative 1, which is going to change the sign over here. It'll change this to positive, but it's going to make the 5 now with a minus sign. So there's no way to rewrite this as the original equation. So this one, the graph of this is not going to be symmetric to the y-axis. Now for the last one, the origin. If you think about the XY grid again, wherever we have a point on the graph, say here, if you think about a line being drawn through the origin, we need an opposite point on the other side for the graph. So this time you can see that the x values become opposites, x and negative x, and the y values become opposites, y and negative y. So to test symmetry with respect to the origin, you need to plug in both negative y and negative x for their respective x and y values. And then you determine if you can write the equation the same. All right, so with this one, I'm going to plug in negative y for y and negative x for x. So I'm going to have negative y squared equals negative x plus 5. So I plugged in both. Plugged in negative y for the y location and negative x for the x location. And then you determine if you can simplify this to make it look like the original equation. So negative y squared, that's going to come out to positive y squared. This one is going to have to stay the same. And then you can see we're at the same spot as this one over here. If I try to multiply through by a negative 1, I'm just going to get this. There's no way to write it as the original equation. So this means the graph of this equation is not going to be symmetric with respect to the origin.